and welcome back to Azure Terraformer. Today I'm going to show you how to set up dependency injection in your Azure Functions solution so that you can take benefit of this very useful way of writing your code in a very unit test friendly way. This will allow you to create components that you can declare very concrete interfaces in front of, which makes it much easier to mock your the various components of your system, and write unit tests around them. So having kind of this dependency injection capability, in my opinion, is pretty important to be able to write clean code, clean and well-tested code with high built-in quality. So it's one of the things that I do every time I start a new project, whether it's an Azure function or anything, in .NET. I want to make sure that I have dependency injection set up. Now, unfortunately, the Azure function default template starts you off with a static class and a static method and really no dependency injection whatsoever. So there's a few things that you got to do to get started. We're going to go through those today and get dependency injection going within your Azure function project. So without further ado, let's drop in. I'll be on my Mac today using Visual Studio. And a little bit on my Linux VM just to see everything else, like hitting the portal, running Postman, all those things. So let's drop in and make those updates, and we'll redeploy using our CD pipeline and make sure that everything still works. You can see that I have this static class here, and that by default that's all that I got. I got one function, with one method within one class. That's it. Now, the first thing that you're going to do is you're going to need a startup class. So you just want to go set up a startup class. The startup class you're probably going to be familiar with if you've done ASP.NET Core development. It's one of those classes where by default you've got dependency injection kind of set up, where lifecycle kind of begins. And there's kind of some middleware configured for you. Now in Azure Functions, a lot of that middleware is kind of abstracted away from you, so you don't have to think about it. So the startup class is not going to look exactly like an ASP.NET Core startup class, but it is kind of important to wire up and inject and configure your dependency injection container with your services and components that you want your Azure Functions to be able to use. So the first thing, this class is actually going to inherit from a class called Function Startup, which I do not have the NuGet package yet installed in my solution in order to get that to work. So right off the bat, the first couple of things that I got to do is I have to go to my NuGet and I have to go add a couple NuGet packages, a couple important ones. So first, you need to use Microsoft.azure.functions.extensions 1.1. That's an important library. That's going to help you. That's going to provide some extension methods that you're going to use within your startup class. But you also need to have Microsoft extensions for dependency injection. So I'm going to go add that. Now, there is a 7.0 version, but I highly recommend that you use a single version. And when you're using .NET 6, like I am, use the 6.0 version. I have tried using 6.01 or 6.02, depending on the assembly. It might have different versions available. I think it's a good idea to stick with 6.0 and keep it uniform everywhere. It seems much more stable that way. So now with these two NuGet packages added, I'm able to resolve this. The Azure Functions extension is the assembly that allows me to resolve this reference here, to declare this, to set up this inheritance between my startup class and this function startup class. Now, if we go and we right click and we look at what we can do, we can implement the abstract class, and boom, we have our configure method. This is pretty much where you're going to be doing your configuration of your dependency injection container. So this is where I can do things like register my interfaces with the concrete implementation that I want to use. So I use this builder.services.add, but it's not there. That's because I need to have a using statement for the extension methods that are going to allow me to do this. This is why we have those extensions. So if I go here and I go using Microsoft.Azure, so adding that namespace allows me to use these add scope, to add singleton, which we all know and love, which allows us to do what I mentioned earlier, associate an interface with a concrete class. And we'll do that here in a second. But basically you've got, T service. I'm just going to stub this out. I'm going to call this my bulk request processor. Because one of the patterns that I often follow is when using event-based architectures, like within Azure Functions, I might have a request that comes in that needs to be processed as like a queue event. And so I'll have a processor that is, handling those queue events and basically doing bulk worker type activities, on the back end, so to speak. And then another pattern that I typically use is a fan out processor, which the fan out processor is designed to basically take a request and split it into a whole bunch of queue messages that then get processed by the bulk request processor. So that's a pattern that I typically follow. You'll see this when as I develop this function a little bit further. But right now we're just trying to get this interface that doesn't exist yet coupled with a concrete implementation, T implementation, and I'm just going to call it, bulk request processor. And we're going to close that out. Now these don't exist yet. I do need a semicolon there. But we're gonna add a project, a class library that's going to have this interface and this class. And so what I typically do is I'll go add a new project and we will call it a class library. We'll make sure that it is the right version of .NET. The reason why I call it .services is because a service is a type of component that implements a bunch of business logic and orchestrates activities based on a request that comes in and generates a response going out. And so I typically set up a services project that will have these components there, where I define interfaces that very cleanly define the boundary between these services. And then the function, whether it's an HTTP trigger or a queue trigger or a time trigger, or whatever trigger, those functions, I think of the function project more as the hosting or the point of execution, right? Where the request comes in and then gets routed to the correct service within my solution. And so the function is really just kind of a way of hosting, the endpoint. You could have multiple different ways of hosting it. It could be a CLI, a console line application. It could be an ASP.NET Core web application, or something like that. But the function host is really kind of that area in the code base that is tightly coupled to the functions libraries. So my services by design will have no idea that they're actually being called from an Azure function. They may or may not know about other dependencies that they draw on other Azure services like blob storage and things like that. But the interface, like where the request comes into this service, is pretty much going to be abstracted from the service component itself. So anyways, you'll kind of see what I'm getting at here. So it by default starts with this class. If I go to my startup and I go get that name, I can go rename this so that it matches. And I've got my class. And so now I'm going to create a new folder just to keep things tidy. And I'm going to call this interfaces. And I'm going to go create a new interface here I guess I could create an empty interface as well. It saves me like a couple of keystrokes. And I'm going to have an empty interface. I'm just going to have my class implement that interface. And all this is doing is it's basically creating a little bit of a proxy between the outside world and this class. And so the outside world can know about the interface, and it can rely on that interface to define the inputs and the outputs that this component will, will accept. And it can, integrate with that interface. But it doesn't have to know about anything beyond like what's going on inside, like behind that interface, what's actually happening inside this class. It doesn't, like the consumer of this interface doesn't care. It's black box. All I know is it's got these methods, it's got these inputs, it's got these outputs. I'm a happy camper, which allows you to kind of decouple the yuck. And I don't say that in a pejorative way, but I use yuck as a very technical term on my channel to describe, kind of unnecessary implementation detail, right? So if I'm a component and I want to get, if I want to have these 3 inputs give me an output, like I don't need to know how you do that, right? I don't need to know what database you talk to. I don't need to know about like what other dependencies that you draw to get your job done. I don't need to know where you went and had lunch. I don't need to know what kind of color your underwear is. Like, it's like, come on, like I'm giving you 3 inputs, just give me an output. That's all I care about. So that's kind of the principle of this design pattern. And it also creates this happy, capability of being able to create alternative implementations. So let's say I build my bulk request processor using Azure Storage Queues. I could replace Azure Storage Queues with Service Bus, and whoever's calling this interface doesn't care. They have no idea. It doesn't matter to them one bit. But this class will then be configured to have the dependencies that it has met. So now that I've got these, so I hope that helps kind of understand the theory behind what I'm doing here. So now I've got these two, I've got my interface and I've got my concrete implementation. I'm going to add a project reference and I've got to add it to my services here. And so right off the bat, there we go. And so now this is going to allow anybody that's hooked up with dependency injection is going to allow me to inject an instance of this concrete class anytime somebody requests this interface. So if I go to my Azure function, I need to set this up in such a way that it supports dependency injection. And the way that you inject dependencies into different classes is you have to have a constructor. So I can't have a constructor like a non-static constructor if it's a static class. You can have a static constructor, but the way dependency injection works is it's not done through static. And then also my static method here needs to be like a regular member method. So I'm converting this static class and static method into a non-static class and to a member method, run. It's called run. So I can just declare a regular constructor that does nothing. And now I can inject my interface called the I. Now the way, like typically what you want to do is inside your class, you want to declare a private read-only instance of that dependency. And then you want to grab the value that comes in through the injection and just save it as that private read-only member variable. Basically, the idea is the reference here will never change, right? Because you get the pointer to this object through the dependency injection, and you never want that to update ever for the life cycle of the instance of this class. Hence, we make it read-only. Private because this pointer, this reference to this object, will be used internally within this class. No other classes need to know about it. And so we're happy as campers. So that's kind of the goal that we're trying to get to. There's a few things I have to do to finish my implementation of my startup class to make this all work though. So if I go back to my startup class, I've set this all up. That's wonderful. But there's something I also need to do. I need to declare, that this startup class is my function startup. So this is like an assembly declaration where I say function startup, and I specify the type of class that I want to be the startup class. GitHub crawler.startup, and there we go. And so now when I go and I implement a method on this class, let's just add a method to my interface, and we'll make it an asynchronous method. Task, do something, async, no parameters, and we'll go implement this interface. Now, I do need to make this async. Okay. So now the thing, something that I want to do is, let's just say I want to return a number, right? So let's change this and just have it return 5. Okay. So that we can be sure, and then I have to go update my interface. Go to definition, task int 5, do something. So this do something is going to return 5. That's what it does. Nothing really fancy going on here. So it's giving me a warning that says I'm not actually using await. So why is this even async? We'll just pat it on the head and move on. So now in my method here, which is already an async method, I have an instance of the thing. So I can basically just say bulk request processor do something async. Now what I'm going to do is I'm going to add this to the log, and I'm just going to say, here's my number. There we go. And now in order to show this working, I'm just going to check in this code, and we're going to run the CD pipeline and make sure that all this stuff works. So you can see I'm running my CD pipeline because I updated my .NET code. We're going to do a build. We're going to do a Terraform apply, which isn't going to do anything because my whole environment is already out there, just sitting pretty, waiting for new versions of the code to be deployed to my Azure function, which is right here. Now while that's going, I'm going to set up Postman here. I already did this yesterday, but I'm going to do it again. And we're just going to add this, and we're going to say /API, and I think it's foo. I should be able to hit the current code out there. Okay, so we have the function returning. Let's just check this out. Looks like the deployment was successful. And we should see, so it just says hello, Mark. I don't actually get to see what's in the logs, right? Now, I might be able to see it if I go to my app insights and go snooping in the logs to see what came back. So let's go look at the logs and see if we can see that. It might be simpler if we just include that in the response. I think next episode I'll probably set up app insights and get all that hooked up now that I have dependency injection set up. So I just pushed this update. And so if I go back here, I should see another action happening. So I'm going to include that number in the response now. So I can continue to hit this. It's not gonna be included. We can kind of cross our fingers and hope we see something. I should probably go to, and there it is, yeah. So we do see it in the logs. So app insights through that, there's a Terraform app insights connection string that I set and instrumentation key that I set in the Terraform code, which I set up last episode, does allow for the log information to come through. There's always like a 5-minute delay, to see, what's coming through from, not 5 minute, I don't know, but there's a delay. in terms of what's coming through. But yeah, so we can kind of see what's happening. Now let's go see, what happens with the deployment. And once this version of the code drops, we will be able to see that the response, when we send a request right now, the response will come back with my number embedded within the response. So previously, and there it is, my number was 5. So the dependency injection is working. We have a function within a function host that is having that bulk request processor injected into it, calling that method on that interface. But because we've injected the concrete implementation of that class, we're actually calling that version of the class, and it's returning 5. So where this is pretty neat in terms of alternative deployments is I can go and create a new alternative class. We'll just call this alt implementation, and we will copy all of the things here, and I will add this to alt implementation. We need to do those things, and this guy will return 10. Okay. Now, in order to get this to work, I need to go to my startup class, and instead of using the bulk request processor, I need to use the alt implementation. And because I'm injecting that different concrete class, instead of returning 5, it's going to return 10. So let me go add the alt, and then we will watch the CD pipeline run again. And then we'll hit Postman, and we'll see that instead of 5 coming back, 10 will be coming back. So there we go, our deployment has succeeded. Let's go hit this and see what happens. And there you have it. My number was 10. And if we go to App Insights, I'm sure we'll see in the log that 10 is the number in the log as well. So this is a very powerful technique to allow you to kind of abstract the implementation detail of your downstream components, where it's a little bit more meaningful than just whether it returns 5 or whether it returns 10. It could be if you're drawing a dependency on SQL database, and in the future you might want to use Cosmos DB or something like that. You can make that change, that major architectural change in that component, and whoever the consumers of that component will, be happy with food in their mouth. They will have no clue, and they'll just keep hitting that interface, getting the response that they expect, and whatever you do behind the scenes, that's your business. Another technique, why this is useful is for unit testing, right? So that we can very easily create mocks, that return maybe hard-coded values, such that we can build a fully functioning user interface, and we don't actually have to spend months and weeks building the actual back end to make it work. We can just have like hard-coded stuff returning real data deployed out into the world. I guess that's 2 use cases, right? One is unit testing, right, where we can create mocks, and then one is more for like scaffolding and putting out placeholders for other development teams that are working on different dependencies, different user interfaces, mobile app, web app, that might be consuming your API, that need data, and they want to see data come back, and they want to test that their app is integrating with your REST API successfully, so they don't want to wait until you're done with all your coding. So you can put in kind of mock implementations that return some dummy data that helps them kind of, lorem ipsum it through, meanwhile you do all the cool things within your backend architecture to get it all working. So it's a very, very powerful technique. This is how you do it with Azure Functions and .NET 6. I hope you found this helpful. And we will continue mission, setting up Azure Functions and .NET 6. Next time, we're going to spend some time really looking at application insights and seeing what we could do with App Insights, how we should set up the logger interface, and all those things. And so now that we've laid the foundation for dependency injection, we can really do a lot of things without doing a whole lot of nasty. I hope you like this content. If you do, smash that like button and consider subscribing to my channel. It really helps out a lot. We got more coming with Azure Functions. Now that we've laid that foundation with GitHub Actions and Terraform, it's going to be super easy to deploy updates to our code and to expand our architecture. So join me next time. This is the Azure Terraformer, signing off.